Computer components. Alan Turing defined a Turing machine as a hypothetical example of solving the mathematical problem known as Entscheidung's problem. Basically, the question was that all problems can have a mechanical way of solution, aka universal computation. Turing machines. The Turing machine has infinite tape on it, which symbols can be read and written. The machine has different states, where depending on the state, it will read or write the tape and move in one direction or the other. Johann von Neumann was responsible for storing data and programs in the same memory. This allowed programs to be manipulated and gave computers a fundamental structure.
Internal components. Internally to a PC are a lot of cables, chips, power supplies, fans and multiple boards. And if not new, quite a bit of dust. The CPU, the central processing unit, is a chip that slots into a standard socket. The control unit and CPU are then sometimes linked as an ALU, arithmetic and logic unit. This is where the input and output devices will be divided by the PC, consisting of central memory store, control unit, arithmetic unit and slow secondary store. The motherboard then connects all components together. Some of these components are: a small disk battery can be found on the motherboard. This allows the clock to continue to keep count when the computer is otherwise off. This is also known as a CMOS battery. I/O connectors allow for standard connection for networking, keyboard and mouse inputs. Memory cards can be added, but the motherboard may constrain the combinations of memory available. Chipsets then control the whole motherboard. Different peripherals have different cards to control them, such as PCI slots or HGP for advanced graphics.
Universal and non-universal computers. Universal computer capable of arbitrary computation, equivalent to a Turing machine. Non-universal, only able to perform limited calculations. Some examples are pocket calculators, central heating controllers and microwave controllers. In general, a computer of any kind is composed of CPU, memory and I/O. Which CPU? Different types for different uses. MIPS, which is contained in silicon graphics, workstations, Sony PlayStations, DVD players, and networking. Intel, contained in desktop computers, laptops, and mobile phones. ARM, Acorn research machines, contained in mobile phones, Blackberries, Nintendo DS, Apple iPod, embedded controllers, televisions and more. MIPS internal structure and RAM. Coprocessor 0 deals with the system control. Coprocessor 1 typically provides support for floating point. Note that coprocessor 0 is not directly accessible from memory. At the very top is the high-level language, HLL. For example, I equals J plus K. A compiler will convert this language into assembly language and decide where in memory to store the data variables. An example of assembly language is the assembler will convert this into binary code.
Operation of computer execution. The operation/execution of a computer tasks follows a specific order and method. Instructions are fetched from an address in the PC, or the program counter. Program counter incremented. Instruction decoded. Data for instruction fetched. Instruction executed. If not halt, then the repeat cycle. A bit of memory. A memory is organised as cells. Memory, RAM. RAM stands for Random Access Memory. This can be both read and written. However, it is volatile, meaning its data will be lost when powered off. Different memory technologies have different characteristics. Historically, we use mercury daylight lines, or sound waves, Williams tubes, cathode ray tubes, magnetic cores and now semiconductors. The two leading RAM types today are dynamic RAM, or DRAM. It must be refreshed regularly or lose integrity. with an access time of 100 nanoseconds, capacity of 16 megabits, and used for main memory. Static RAM or SRAM, which has no refresh required, an access time of 10 nanoseconds, the capacity of 1 megabit, which is used for cache memory.
Memory, ROM. ROM stands for read-only memory. Written only once, which is during manufacture, can only be read by you. It is non-volatile. Some of its applications: stores simple boot sequences in recovery programs, devices where programs seldom needs to be changed. The different types of ROM: ROM, written once, factory; PROM, programmable ROM, written once by the customer; EEPROM, erasable PROM, many times by the customer; EEPROM, electrically erased PROM, many times by the customer. External memory. Examples of external memory: floppy disks, CDs, DVDs, hard disks, USB memory. Examples of input-output units: input devices such as keyboard or mouse, and output devices screen printer.
School of Mathematical and Computer Sciences.